Hi there. Today we're going to start on solving problems using sinusoidal functions, and then we're going to do 8.5. This is probably the most important topic. However, you already have a lot of the tools to do these things. So it's the most important in that you're probably going to get a question like this on your exam, or one of the questions we're going to talk about today. But you have a lot of the tools to do this already. So we're going to do some sinusoidal stuff, and then we'll use some of the tools you have from other topics that you've already learned. All right, now I have to mention to you that, yeah, it's all right. Okay, never mind. All right, so let's read this. Janelle is helping Justine study for her applied math exam. Janelle suggests they go jump on the bed. She notes, as Janella jumps, her minimum height is 36 inches above the ground, because she's on the bed. So she's already kind of off the ground because she's standing on the bed. Okay, so that's the minimum height. That's pretty important. Maybe I'll just give that a quick circle. Her maximum height is 42 inches higher than her minimum height. So she's jumping up 42 inches. I don't know if that's a good jump height or not. I don't know. Anyway, she reaches her maximum height every 1.5 seconds. So from the maximum, it takes 1.5 seconds for her to get back up to the maximum. So maximum to maximum, 1.5 seconds. That's pretty important. Let's give that a circle too. Create a table of values. All right. This is the type of question that I'm expecting you to get on your exam. There's this kind of, I would say this happens every exam or every other exam probably. I usually like to make a three column table because I find that helps me. X, Y, and then we do positional. I'll show you what I mean in a second. Okay, let's start at the beginning. She's standing on the bed. So X is 0 because time is 0. We're just starting here. How high is she? Well, if she's standing on the bed, she's at her minimum height, which is 36. And I would call that a minimum. Now, I want to skip this a little bit. I want to go to the end of the chart. How long does it take for her to go through one full cycle? Well, if it takes 1.5 seconds to go from, I don't know why I drew a line there, but to go from maximum to maximum, then it would be 1.5 seconds to go from minimum to minimum, because that's what the period is, right? That's one full cycle. And you can measure that from different places. So it would take her 1.5 seconds to go from minimum all the way up and all the way back down to minimum. So I'm just going to skip to the end and throw a minimum on there. What height is she at the minimum? She's at 36, and that's a minimum. Now, for your calculator to be able to recognize what type of graph this is and be able to give you some values for A, B, C, D, you have to give it at least 5 values. So you have to give them a minimum, a maximum, and a midpoint. And you have to kind of give them the whole cycle. So what I'm going to do here is right in the middle, in this particular graph, I think about a minimum. Halfway in between there is going to be a maximum, right? So I'm going to put a max physically in the middle of my chart, and I know that that will be physically in the middle of my graph as well. How high is she at her maximum? Well, she's 42 inches taller than 36, or higher than 36, so that's 78. And that's going to be beautifully in the middle of these two minimums, right? So it's going to take half the amount of time as it did from this whole cycle. So what's half of 1.5? 0.75. Because this thing is beautifully symmetrical, and that's kind of what I'm relying on. Now, if I put this in, my calculator won't be able to recognize it. It'll give you some weird error. So we need to put midpoints in here too. I don't really need them for graphing. It's nice to have, but I don't really need it for graphing. I just need it for your calculator. So I want to find these points in the middle. Good news, it's beautifully, again, halfway in between. So what's halfway between 0 and 0.75? Well, I'm just going to do this off to the side here. 0 plus 0.75 divided by 2. It gives me 3 decimal places, and normally I would say round, but when you're doing a chart, don't round. Use more decimal places. And then Your height is going to be beautifully in between the minimum and the maximum as well, so that's awesome. It's going to be beautifully in between. What's halfway between these two things? Well, 36 plus 78 divided by 2, I'm basically finding an average, 57. And then this last point is really easy. It's going to be a midpoint again, which will be 57. And each step here, I'm going up by 0.375. So 0.75 plus 3.75, 1.125. And you'll notice that this is perfectly spaced out. Like it's the same jump we're making every time here. That's enough for my calculator. Let's go to my calculator now. We know how to do this. Go to my list, clear the junk I had in there, clear. Enter this in. I'm going to use those 3 decimal places when I have them. Double check it as I go, just make sure I don't type in anything incorrectly or else it'll change my whole answer, unfortunately. Okay, I want to find a regression equation, so let's go stat, over to calc. It's a sinusoidal regression, so there we go. C for me, hit enter, might have to enter more than once, and there we go. 21. I'm copying down the format they have on my calculator because that's going to be the format that makes sense for this. So 4.19. We can round it off to 2 decimal places now because this is just us writing down our answer. It's not, we're not really using what I have on my sheet here. And I could have done this by hand if I wanted to. You might end up with a different shift if you do it by hand, and that's totally fine. We end up with the same thing. Okay, beautiful. Let's draw a clearly labeled graph. I'm going to add some lines on this. I know I'm not going to be going into the negative distance. I'm not going to be going negative time, so I'm just going to focus on quadrant 1 here. Whoops, kind of missed. All right. Along my x is time. It is in seconds. Along my y is in height. In inches. Now here's something specific that I want to make sure you read because I just jumped to doing it here. Draw a clearly labeled diagram graph which represents 2 complete jumps. This is 1 complete jump, so I want to do 2 of them. So if 1 complete jump takes 1.5 seconds, I need 3 seconds. So I'm going to take 4 boxes to go up by 0.5, I think. 1, 2, 3, 4. And I think that will work out fine for spacing. Guaranteed you will get a question on your exam where you have to graph something. I would bet money on that one right there. And then I think here I'm just going to go by 10s. It's not perfect, but it's all right. Alrighty. Let's throw some points on here, and I'm just kind of guessing as to where they should be because 0.375, that's, that's hard to kind of figure out. So I'm just kind of guessing as to where it should be. It's not perfect. Oops, forgot about this one. We don't need it to be perfect. We need it to be just kind of close, that's all. 36, 78. Lost where I was there for a second there. Okay. Maybe around here. And I can see this pattern start to emerge. So that when I have 1 cycle down, I can see what this next cycle is going to be without me having to do a ton of work. I even like to just jump to the end usually. And I can even kind of guesstimate where these values are going to be. Kind of right in here somewhere. I could certainly find them, but I'm kind of lazy. So here we go. Let's draw ourselves a beautiful curvy curve. We don't want it to have corners on it because that's not what we would have on here. There we go. We could probably put an arrow here. We don't want to put an arrow to the left because that's negative time. That doesn't make any sense. And there we go. Beautiful graph. Let's try this one now. Using your equation from earlier, determine when Janella will reach a height of 60 inches above the ground for the first time. Explain how you arrived at your answer, 2 decimal places. Okay, so I want to use this. I do not want to use the rounded version of this, so I'm going to go y equals, clear this, copy paste, so vars 5 over to EQ and enter. Okay, probably have to change my window settings. I'm going to change it to exactly what I have here, because I know that that's going to work out well. Oops, going up by 0 to 80, going up by 10. And my graph should look like what I have on my page. Beautiful. Okay, now it asked me for when we reach a height of 60. Height is a y value. So to find where I have a y value, I need to make another line. I don't know what that was. Take a look at it. And we hit 60 inches a bunch of times, but they only asked me for the first one. So that's the one I want right there. So second trace, 5 for intersection. I need to get close to that, or else it'll give me a different one. I'm going to use my little cursor to get close enough to it. You know, it doesn't be right on, but just, so I'm right there. Yeah, I'm pretty much right on. Hit enter 3 times. There we go. So 0.53 seconds. And you could certainly explain how you figured that out. Okay, last one here. Justine decides to take her turn. She believes that she can jump higher than Janella. She believes because of the bed, her minimum height will be the same, but that she will jump higher than her. Change the sinusoidal equation to represent Justine's movement on the bed. Explain which values you change and why. Okay, so I think let's keep this as simple as we can. Let's try and draw it right on here to see if we can figure it out. Her minimum height is going to stay the same, but she's going to go taller because she's apparently an MBA star. She's going to go taller. I'm going to keep it simple, and I want to keep the period the same, so she's going to meet the bottom at the same time, but then she's going to go taller again. So let's just draw that on here so we have a bit of a visual. Just going to label that Justine. And then let's think about what would change in our equation. Now, the minimum doesn't change, but that's not really a part of our equation, is it? So I'm just going to write down kind of your basic equation. Our amplitude changes, right? That gets bigger because the height of our function gets bigger. So A would be bigger. I did not change the period because it's still taking me 1.5 seconds to go all the way down, so that stays the same. My starting point is the same, so my phase shift does not change. But my midline is way up here now, so my midline would also get bigger. Nice. Alrighty, let's flip. Let's try another one. This is a hard one, but very, very similar. So what we're going to do is we're going to set it up, and then we're going to leave you to finish it off, because once we set it up, it's the exact same skills as you've used before, but the setup is difficult. Alright, so the pendulum of a clock is swinging from left to right. So it's going from left to right, and then it'll come back again. It's you know, like a grandfather clock, how they have a thing that swings back and forth? That's what this is. At its minimum height, the bottom of the pendulum is 12 inches from the ground. So right here, minimum height, 12. During its swing, the bottom of the pendulum rises 5 inches from the minimum height. So from here to the maximum height would be 17 inches. 5 inches there. Okay. The time it takes for the bottom of the pendulum to swing from its minimum height to its maximum is 4 seconds. So from here to here, that's going to take 4 seconds. They're trying to help scaffold it a little bit with that picture. Determine the sinusoidal equation. To do that, we can come up with a sinusoidal equation by figuring out the midpoint, figuring out the period, yada yada. I like to do it with a table of values. If you'd like to do it truly by hand, you go right ahead. I'm going to do it with a table of values, and then I'm going to use my calculator. Alright, so let's start off from this point, and then we'll go to this point, and we'll come back, and we'll see what happens. So all we really care about here is how high the pendulum is. We don't care if it's going to the left or to the right. We just want to know about how high it is. So at time 0, starting here, our height is 12, and that would be a minimum point. Let's skip down to the next minimum point. So it would go this way, it would go up, and it would come back down. So it kind of looks like it would go up, and it would come back down. That's us just going here. And then when it does this, it would go up and come back down. So it would go up and come back down. So one kind of full swing here is actually 2 cycles. All right, so let's try and think about the time it takes for the bottom of the pendulum to swing from its minimum to the maximum is 4 seconds. So there'll be a maximum right in the middle here, and that should take 4 seconds. What's the y value of the maximum? Well, that would be 17. And then if it takes 4 seconds to get up, it should take 4 seconds to get back down. So that would be 8 seconds now. Don't go back to 0 because remember, x should always continue on. We should never have the same values in x. Y values we can have the same, but x should always be increasing over time. And then if it's a minimum point, that would be 12 again. Now, I just need some midpoints here to round this out a bit. So halfway between 12 and 17 would be 14.5. Halfway between 0 and 4 would be 2, and then 6. This is enough for us, our calculator, to be able to give us an equation. So let's go ahead and just type it in real quick. Stat, over to calc, find that sine reg, hit enter, there we go. Write her down, 2 decimal places. And then we'll just double check that it makes sense with what we know. Just like a really quick little check. For example, 14.5 should be the midpoint. That's what I have. Great, that makes sense to me. Halfway in between here. 2.5 should be the height. So from 12 to 14.5 is 2.5. From 14.5 to 17 is 2.5. That's great. We could certainly look at the b value if we wanted to. All right, now there's a couple questions. You know how to do this. We're just graphing it and finding stuff. So let's focus on the stuff that we don't know how to do. Alrighty, flip one more time here. Let's see what else we got. Here's 8.5, and 8.5 is just pulling it all together. So it's really just putting everything together in one little topic. Let's do this one question, and then we'll be done. Sinusoidal functions. All right, let's read. The average temperature of Gimli was recorded every second month for the past year. January, March, blah, blah, blah. Okay, some temperatures. Assuming January is month 1, determine the sinusoidal equation for the data. So this is another really common type of question where they give you the table of values and you have to find stuff. But we know how to do that. We know how to do that, right? We know how to find y values and x values and minimums and maximums. We know how to do that. None of this is new here. So January is month 1. What should March be? I don't think 2, because then what would February be, right? I'd say March should be 3 probably, and then May is 5, 7, 9, 11. So when I put this in my chart, my calculator, you know, these are the x values I'm going to use. And I'm really quick at this point because I've practiced so much. I've done so many very similar questions. None of this is new to me here. The only thing I might do is actually type something in wrong, and that'd be annoying, but fixable. Oh shoot, seems like I did that one. Okay, done. Find the sinusoidal equation. We're going to stat, over to calc, find that sine reg, hit enter, write her down. Round it to 2 decimal places. I'm just going to write it down the way they have it stated up here. So that's where my brackets are. That's where I'm going to put my brackets. Basically just copying it down. I have an equation. Great. Using your sinusoidal equation, determine the average temperature for the month of June, and it says interpolation. Now, this is an interesting word to know, but it's extra information. Interpolation means, let's say I have these dots of data. You can't see that. Dots of data. Interpolation means find a dot that would be in the middle of two. So interpolate, find in the between. Extrapolate would be, okay, here's some dots. What happens next? Question mark. So interpolate is in between your data values. Extrapolate is what happens after your data points. That's all that means. Anyway, month of June, that'd be an X value, which would be 6. I'm going to graph this guy. And this should be just straight up out of your memory. You've done this so many times. I probably do have to adjust my window settings a bit, but that's all right. I'm going to go up to 12 months. Just going up by ones. I'm going to go down to maybe negative 20, up to like maybe 30 degrees. Just a guess, going up by 5 degrees. Look at that curve. That's what I'm expecting. Great. Notice my calculator is in radians. That's going to be typically where our calculator is going to need to be. So if you get something crazy, try to adjust from radians to degrees or degrees to radians. Typically we're going to be in degrees or radians, or we're going to be in radians most of the time. I want to know when x is 6, what is y? So second trace, 1 for value, 6. We're not spending a lot of time on this because we have done this so many times, right? What's my unit? It's a temperature, so it's degrees Celsius. Average temperature for the month of December. Well, that would be x equals 12. All right. Second trace, 1, 12. Way over there, right on the edge of my screen, actually. I might have to adjust my window settings if I only made it to like 11. Negative 12.14 degrees Celsius. We're done. That's it. Same skills as you've known before, right? And that's sinusoidal functions. We're done. Congratulations. Otherwise, try some practice. Have a good night.